there is a puzzle here either way, which is that on pre-training, when we train the model on pre-training, we use like trillions of tokens, right? And humans don't see trillions of words. So there is an actual sample efficiency difference here. There is actually something different that's happening here, which is that the models start from scratch and, they have to get much more training. But we also see that once they're trained, if we give them a long context length, the only thing blocking a long context length is like inference. But if we give them like a context length of 1 million, they're very good at learning and adapting within that context length. And so I don't know the full answer to this, but I think there's something going on that pre-training, it's not like the process of humans learning. It's somewhere between the process of humans learning and the process of human evolution. It's somewhere between, like we get many of our priors from evolution. Our brain isn't just a blank slate, right? Whole books have been written about, I think the language models, they're much more blank slates. They literally start as like random weights, whereas the human brain starts with all these regions. It's connected to all these inputs and outputs. And so maybe we should think of pre-training, and for that matter, RL as well, as being something that exists in the middle space between human evolution and, kind of human on the spot learning, and as the in-context learning that the models do as something between long-term human learning and short-term human learning. So, there's this hierarchy of like, there's evolution, there's long-term learning, there's short-term learning, and there's just human reaction. And the LLM phases exist along this spectrum, but not necessarily exactly at the same points. There's no analog to some of the human modes of learning. The LLMs are kind of falling between the points. Does that make sense?
Yes, although some things are still a bit confusing. For example, if the analogy is that this is like evolution, so it's fine that it's not that sample efficient, then like, well, if we're going to get the kind of super sample efficient agent from in-context learning, why are we bothering to build in, there's RL environment companies which are, it seems like what they're doing is they're teaching it how to use this API, how to use Slack, how to use whatever. It's confusing to me why there's so much emphasis on that if the kind of agent that can just learn on the fly is emerging or is going to soon emerge or has already emerged.
Yeah. So I can't speak for the emphasis of anyone else. I can only talk about how we think about it. I think the way we think about it is, the goal is not to teach the model every possible skill within RL, just as we don't do that within pre-training, right? Within pre-training, we're not trying to expose the model to, every possible way that words could be put together, right? Where it's rather that the model trains on a lot of things and then it reaches generalization across pre-training, right? That was the transition from GPT-1 to GPT-2 that I saw up close, which is like, the model reaches a point. I like had these moments where I was like, oh yeah, you just give the model a list of numbers that's like, this is the cost of the house, this is the square feet of the house, and the model completes the pattern and does linear regression. Like, not great, but it does it, but it's never seen that exact thing before. And so to the extent that we are building these RL environments, the goal is very similar to what was done 5 or 10 years ago with pre-training. We're trying to get a whole bunch of data, not because we want to cover a specific document or a specific skill, but because we want to generalize.